Calculate the current through 2 ohm resistor, that is 2 ohm resistor, by making use of source transformation to first simplify the circuit. Source transformation should be used, that is clear. First, what we can do? See, initially what we are doing, we are going to convert into voltage source. This the voltage source is connected into the parallel 3 ohms, so we can convert it into voltage source. 5 V is equals to IR, so 5 3s are 15 volts. Then in series with resistor, you will get a resistor. This resistance will be taken off. Why? Because we are converting current source into voltage source. We will get here 3 ohms. Then next 4 ohms, other all connections will be same. And here again, lastly, if you see, the current source is connected with the resistor, same like this. We can convert into voltage source. V is equals to N 9 into 1 ampere, that is 9 volts. And again, this should be connected in series with the current source. 9 ohms will be connected in current source. And again here, if you see another transformation, there are 3 totally. Here there is a dependent source. Which dependent source is voltage dependent current source it is. Okay, in the initial videos I've already explained about dependent sources. Dependent sources will be in the form of in the triangle, and here it is voltage dependent current source, as it is depending on the voltage source. The current is depending on the voltage source. Okay, here also we can convert into voltage source. Why? Because this is a current source. Voltage source is what? 3 Vx into 17, nothing but 51 Vx. It is connected with the resistance 17 ohm. As here it is parallel with current source, it should be resistance should be in series with the voltage source. In this way we are going to convert initially. These all steps. These all current source into voltage source. After that, what will you do? After that, what happens is we convert this voltage source in resistance into current source again. Why? Because we need to simplify the circuit using source transformation. It comes into one loop. One mesh only should be there, so that it will be easy for us to apply KVL and find the current through it. So what we'll do, again this voltage source in series with resistance will be converted into current source. Same 15. This if you see carefully, 4 and 3 is in series, so we can add up. So 4 plus 3 is 7 ohms. It is added up, and 15 by 7 ampere is the current. So I is equals to V by R. This is totally 7. So 15 by 7, and this resistor in series will be connected into parallel 7 ohm. This 7 ohm is already initially present. This all equation is same, and if you see here 17 ohm and 9 ohm is also in series. Okay, so we can add up them, 26 ohms, and we are not going to disturb this. Why? Because we want current through this. So till last we are not going to disturb that. Why? Because we want current through that. We should not disturb that. Why? Because we need current through that. Okay, remember that. And this 9 volts. Okay, then after that what happens? Again what happens is this 7 and 7, if you take the as the resistance are in parallel, what we'll do, we are going to convert into we are going to not convert, but we are going to calculate the parallel resistances, so that we can write in this way, in series form. So 7 into 7 by 7 plus 7, nothing but 1 by 7 plus 1 by 7. If you do, you will get 3.5 as the answer. 3.5 as the answer. Then this 15 by 7 is 7.5 volt. We have written in the decimal form. Then this same, the other components are same, 26 ohm, 51 Vx, as everything is same. After this, what we do? See, now what you can see here, there are many meshes, many meshes are there. 1, 2, 3, 4, many meshes are there. We are converting into single mesh. After converting to single mesh, what we will do? We will going to apply KVL. By applying KVL, what we get? See, here same, again consider plus minus. Here consider plus minus. Again it is already given plus minus. Okay, then this is plus minus. See, plus 7.5 minus 3.5 I. Why? Because I is the current flowing through it. Again minus plus, the end one is what? Plus, plus 51 Vx minus 26 I minus 2i minus 9. The end sign is minus. So minus 9 equals to 0. If you calculate this and rearrange, then you get in this form. But we don't know the value of Vx. So how to know the Vx? See, as it is in this one loop itself, Vx means what? The voltage at 2 ohm. Voltage at 2 ohm is what? This total I current into resistor, no? So 2 into I. Okay, Vx is nothing but total current I into 2 ohms. You'll get the voltage drop across this resistance. So Vx is equal to 2I. If you mention this also in this form, then you'll get all in terms of I. So I can be calculated. You'll get it 0.02128. I is equals to what? 21.28 milliampere. Shift 3 times. 21.28 milliampere. Okay. These sums are not tough at all. You need to understand the KVL mainly here, and so that you can easily calculate. First, we need to know the source transformation. The main thing is what? If current is in parallel with the resistor, convert into voltage source. If voltage is in series with the resistance, convert into current source with parallel. So that it will make the circuit easier, and you need to do that source transformation until you get one loop itself, so that it will be easy for you to calculate the current or anything, power at the resistance. Here the questions can be in different form. Here they've asked the current through resistor. Sometimes they'll ask the power dissipated at this resistor 2 ohms. Then what we'll do? P is equals to VI, or P is equals to I square R. P is equals to V square by R. Like that, there are different formulas already discussed in first video. How we can write P in terms of I into I and R and V and R. So using that, you can easily calculate, and we can bring into a simple circuit with one mesh and one loop. We can directly apply KVL and we can get the values. So source transformation is important.